Hey everyone, welcome back to the MHS Computer Science channel. And so today I'm going to be going over this problem that I made for the freshman Bridge CTF that happened, I believe, on the last day. And so no one solved this, which I kind of really did expect to happen because I wanted it to just sort of be a learning opportunity and an opportunity to see like what actual hard problems would look like. And so this is one of those. So it says, I'd like to use small encryption or small keys for my XOR encryption. By small, I mean very small. Show me why this sucks. So if you're not familiar with XOR encryption, you could go ahead and maybe highlight this and search it up. And essentially what XOR is, down to the simplest level here, I can open up this real quick. So down to the simplest level, all XOR is a Boolean expression. So let's say you have some string of binary like 100110001. Right? So let's say this is your binary and you want to XOR this with 000100011. And so what you do is you do this bitwise. So 1 XOR'd with 0 would be 1 because it's the exclusive OR operator. So if it was just 1 or 0, it would still be 1. And then 0 XOR 0 would be 0 because none of them are true. And then once again, this would be 0. Now 1 XOR 1, we said this is the exclusive OR. So it's both of them are true, but they can't both be true, right? So this is actually going to be 0. And then 1 XOR'd with 0 would be 1. And then 0 XOR'd with 0 would be 0. And then 0 XOR 1 would be 1. And then 1 XOR 1 would be 0. And so you can, all we've essentially done is XOR these two bits of binary together to create this. And what you could do is even reverse this process. You could XOR this with this and you'd get this, right? So we could try that. So 1 XOR'd with 0 would be 1. 0 with 0 would be 0. 0, 0, 0. And again, 0 XOR'd with 1 would be 1. 1 XOR'd with 0 would be 1, right? And you get the whole idea. And so what you can do is do this with very long strings of binary, also known as converting text to binary. And you can essentially do the same process. So I can do something like XOR. I could XOR like the string hello with the string ASD, right? And it would give me some gibberish because it's performing that same process and it's still trying to convert it. So what I can do is just open up a little Python 3 and I'm going to use Pwn tools that will actually, it has a XOR tool that you can use. So it's very nice. And then, yeah, so from Pwn import XOR. And I believe when I demoed this in class, I had some issues and I do know why I was having issues now. I will get to that later. And so I just imported XOR. So let's just test out XOR hello. And then, so you want to put the string that you want to XOR first and then the key. So the key will be just ASD, right? And it will give us this gibberish. And so then you could essentially just like reverse the process. If you know the key, you could XOR this with ASD and you'd get hello back, right? So it's a viable part of encryption. So now we can actually get to the problem at hand. And before we do, let's go ahead and take a look at this hint. And this looks to be source code. So this is just a simple bash interpreter line, how Linux or how bash can actually figure out which interpreter you're supposed to use for this. So it's importing the XOR and it's going to, from OS import urandom. So what urandom does is it essentially generates a random string of bytes of however many times you specified. So let me go ahead and just test this out from OS import urandom. And we could do something like urandom, and then let's say I want something 4 bytes long. And you see, that is 4 bytes long. So 1, 2, 3, 4. Maybe what if I want urandom of 2, right? 1, 2. And it would be completely random every single time. So I could keep just doing this over and over and over and over and over, and it would give me 2 random. It would give me 2 random bytes every single time. And so it's also importing Base64 encode. So if I wanted to Base64 encode something from the command line, I could just do something like echo. What if I want to convert hello to Base64? We're going to pipe that to Base64. If that'll work. All right. So then it will give me this. And then what I could do is just echo this out. I'm just doing a little bit of Linux terminal stuff. And then so I can do something like Base64. And this will decode the Base64 and get back hello. So now we can go ahead and look at our main program here. So the message is obviously going to be redacted, right? Because it will most likely be the flag. So we're looking at source code. And the key is going to be urandom of 1, right? So it's generating one singular byte from the range of 0xFF to 0x00, or from technically from 0x00 to 0xFF, right? And Python interprets those as integers. So if I type 0x00, it will interpret that as 0. 0xFF will be interpreted as 255. So we know that this is going to be literally 1 byte long. So we could just go ahead and look at that, right? So this is 0xF6. So I could do something like 0xF6, and that's 246. That's within 0 to 255. So we know that the key is going to be somewhere between the integer value of 0 and 255. So we already kind of have a little bit of a edge in our heads, right? So we know it's going to be 255, or from 0 to 255, sorry. And then, so now we can see how it's encrypting it. So the ciphertext is going to be the Base64 encoding of XORing the message and the key. So it's first going to XOR the flag with the key, and then it's going to Base64 encode it and put that into a variable called ciphertext. And then all this is doing is essentially writing to a file called ciphertext.txt what the ciphertext is. So we've downloaded it down here. You can't see it because for some reason my Windows taskbar is showing. So let me go ahead and go to our downloads folder, and then I'm just going to open ciphertext.txt. Okay, so we know that this is, now that we look at this, we could kind of reverse engineer the process in our head. So if we wanted to recover the original XOR message, all we have to do is just Base64 decode it. And then once we Base64 decode it, we can cross this out, and now we're just left with this. So we can sort of start to write a script here. So I'm just going to write to script.py, and then I'm going to use an interpreter line. And then I'm going to first import XOR. I'm going to also import Base64 decode. So now what we're going to do is open the ciphertext file as a context manager, and then we're just going to write to CT. The CT variable is going to be essentially whatever is inside of this file. So I'm going to do h.read to read the file, and then let's just make sure that worked. So I want to print CT. Okay, so now let's just go ahead and run that script. Okay, perfect. So we have successfully extracted what's in the file. So now what we can do is do something like h.read, and then we want to actually Base64 decode that. So Base64 decode, and then whatever is in that file. And now let's see what it gives us. Okay, so this is the XORed message. So now we can actually work with this. So now we could just kind of test this out. So what if I wanted to try, so we're going to try to recover the key, and we know that the key is between 0x00 and 0xFF, right? So we know it's between 0x00 and 0xFF, which is 0 to 255. So we can do something called brute forcing, or essentially testing all possible combinations and seeing if we can find a match. So just to start this off, make sure our XOR is working. We can go ahead and print. Let's go ahead and try XORing the ciphertext with 12, or I guess that would be, hopefully I can do this in my head, 0xa, I think. Oh, wow. Okay. So, never mind. 0xa2. Oh, okay. It seems I'm not very trained in my hexadecimal. So, I'm just going to use 12. It'll interpret it as integer already, so 12. And then let's just go ahead and print that. Okay, good. So we know it's working. So we've tried to XOR this message against 12. So now what we want to do is do something like a for loop to iterate through all possible combinations from 0 to 255. And then we want to XOR it with that integer and then see what we get back. So we can do something like for I in range of 256, because if you read the range documentation, I can actually pull it up. Range Python. We want to read the range documentation, and then let's see if I can find this. This is not the official documentation, but I can go ahead and find this. So it says not included. So we know that it's, if I were to do something like range 255, it wouldn't include 255 because it's going from 0 to 254, which means range is inclusive. So that's why I'm doing 256 here, so that it can also include 255. Anyways, so for I in range of 256, we want to XOR the ciphertext with I. So whenever I is like 25, it'll XOR the message with 25. And then we want to go ahead and actually print that. And yeah, so let's just go ahead and see what that looks like. Oh, I spelled it wrong. My fault. There we go. Well, I need to save that. Wow, I keep spelling it wrong. That's funny. Okay, there we go. So it's just going very super fast, and it's just a bunch of gibberish on the screen here. Let me actually exit out of this so you can get a better look. It's just going as fast as it can and just dumping everything into the terminal, right? So we need to actually do some sort of like finding, right? So we need to actually do something like actually, I'm going to assign this to a variable, a equals this. And then we want to do something like if a certain string of text is inside of a, then we want to go ahead and print a and print at whatever I equals at that exact moment. So what we could do is something like if, remember, we need flag in a. If the flag string is in a, then what we want to do is print a and print I. And I actually need to get rid of this. And yeah, so what we're essentially doing is XORing this, and then if the flag string is in that XORed product, then we're gonna go ahead and print everything. So let's go to, oh, okay, so it's dumping this out in bytes, as you can see by this prefix. So what I need to do is actually put a B there to show that this is supposed to be bytes instead. So now let's go ahead and try that again. And look at that. We've got a match at when I equals 191. So it says, my name is Chris, and I like to single byte XOR strings because it's funny. And then we get our flag here. So that's a basic crypto brute force mechanism, right? Because we know that the key is most likely very small. Or, yeah, we know the key is super small. So that's how we know we can actually just brute force through every single possible combination. And, yeah, there you go.